I also make a lot of use of sequences. So sequences are basically kind of like sets, but each item is also has some index associated with it. It can be also thought of as a dictionary mapping from some set of natural numbers to some other set. And this is the notation that I use when I'm describing it. You know it's describing the set of sequences when you see the this double barred come here. Brackets. And then putting the subscript underneath is basically just limiting what the length is allowed to be. My pen stopped working. That's not so good. Okay. I've got some pretty funky notation as well for when I want to do modulo indexing into a sequence. That's this anti-clockwise superscripted arrow. And it really just means, yeah, modulo subscript. Okay. Pretty standard construction, syntax for construction. Nothing particularly out of the ordinary there for sets, but for sequences, I make it clear that it's a sequence that is being done. So I have a slightly different membership symbol here, very similar to the regular membership, but just more angular. So it's this kind of less than with an extra line in the middle, and this just means ordered membership. So it's like we take a sequence and we draw something from it in order and then construct a new sequence by some function on that. We have some funky stuff for like ordering sequences, so taking some set and then applying an order to it to create a sequence. And that's what this wavy line means. I'm not going to go too deeply into the wavy line notation. It should be pretty clear when you read the definition. But in essence, it allows you to provide a term so that you can specify how a set should, or indeed a sequence, should be ordered or reordered. Let's see if this works. It does. Good. So, for example, -I wavy line, I exists in some set of numbers. We'll order that set of numbers in the other direction, from high to low. That's due to the negative sign, right? Good. And then we have the double wavy line here, which removes duplicates, as you can see there. It turns out that these particular bits of notation are very useful later on when we're specifying some of the protocol. We also assume some inherent ordering of sequences whose elements are themselves ordered. Just standard dictionary ordering. We have the frown operator, pretty standard operator for concatenation of sequences. I also use the frown operator as a, whatever you put it, like on top of, in this position on top of the term, to basically just mean take the term and concatenate all of its parts. We have the double plus operator for adding a specific item onto the end, like appending, basically. And we have an above arrow notation here, which I'll probably remove in the not too distant future. But at present, it basically just means take the first n items or the last n items. For the first n items, this one, it's just exactly the same as saying s 0 ... n, which don't really need any exotic syntax for. That one will do just as well. For the last n items, we don't really have an easy syntax to say that, and that's why this back arrow is in here. We have a transpose operator, again, pretty standard notation there. Yes, and then we have sequence subtraction, which is similar to the set subtraction operator, this backslash. We know that it's sequences that we're messing around with due to having this extra little circle in the top left. And in this case, we remove the leftmost element. Yeah. For sets, it doesn't matter because, every element in a set is unique, so we can unambiguously remove an item of a particular value. We can't do the same with sequences because there may be the same value in multiple elements of the sequence. And so we need this. We need to specify whether we mean the leftmost or the rightmost or something else. In this case, we don't care. We just want the leftmost. We have Boolean values, and I'm a little bit for Boolean values, I kind of basically equate true and false to 0 and 1. Other way around, obviously. True is 1, false is 0. It's a pain having to write, if it's true, I mean 1. If it's false, I mean 0 everywhere. So I just kind of say they're the same thing. And we have this bits function that lets us take some bytes, which is blackboard Y, and turn it into a sequence of binary items. We actually say octets, not bytes, in the document. Bytes can, they don't generally, but they can technically mean things other than 8 bits. So to make it unambiguous, we use octets. Blobs are sequences of bytes. They are represented by this Y, blackboard Y. If I need a specific length of blob, then I subscript with that length, in this case, X. That just means a byte sequence, X bytes long. Finally, I do use a shuffling, and we have a shuffle function, calligraphic F, this guy. It's defined properly later, but it's basically the Fisher-Yates shuffle, classic shuffle algorithm.